let me just.
Recording in progress.
Right. You need to know your objectives because let's study that and
Recording
continue.
in progress.
Right. So I was saying before you do any topic, you should know your syllabus objectives to know exactly what you should be learning for your exam. Because it's not really wise to, delve into a topic and you don't know exactly what you should be learning, right? Right. That's why it's important for you to follow your syllabus. Okay. So kinematics. Let me just go on. This is the third section of your syllabus and it's introductory calculus. And kinematics comes under this, right? So you'll see it in differentiation. Hold on, where is it? Okay, here. So when you're doing rates of change for differentiation, it actually involves kinematics, right? So we'll be doing that soon. So it's important for you to know, basic differentiation and how to do rates of change. And that's why I did it last class, right? Because you're required to have that skill before you start kinematics. And you would also be required to apply integration when doing kinematics, for displacement, velocity, and acceleration. You need to know these, right? So yeah, it's important for you to know how to differentiate and how to integrate when you're doing kinematics. But for today's class, we're not really doing that. We're just doing the basics, right? Because you need a fundamental. You need to understand the fundamentals before you could, do those advanced things with all this calculus and all that. So kinematics, what are you required to know for your syllabus? Well, you need to know these definitions, right? Yes, I know you're doing math. You don't want to learn definitions, but you have to. You have to in order to do kinematics. If you don't understand the terms, then you wouldn't be able to do this particular topic. So there's a whole list of definitions that you need to know, some formulae you need to know, and graphs. If you don't like plotting graphs, well, you need to start to like plotting graphs because this particular topic, you're required to know how to plot graphs. The only year where you weren't required to plot a graph was in 2021. But the rest of years, yeah, you had to plot a graph. So you need to make sure your graphing skills are on point. Right, let's start. So my physics students, I don't think this would be new to you because you learn kinematics very early in Form 4. But for my non-physics students, kinematics is actually the study of motion. So it explains, it's the study of motion. So it explains how a body moves. That's just the definition of kinematics, right? And it comes from a Greek word, kinema, which means motion. Yeah. Like I said, you have to know definitions. If you don't know the terms, don't understand the terms, so it's not just about memorizing, right? It's about understanding the terms. If you don't understand the terms, then you would have some trouble with this topic. Right. Displacement. We actually meant this when we were doing vectors, right? Displacement is the distance traveled in a specific direction, or you might see it's a change in position of an object, and it's a vector. Why is it a vector? because when we were doing vectors, we said that the definition of a vector is a quantity I have no idea what's happening. Anyways, let me continue. I don't know what just happened, but it's okay. From point A to point B, I told you that's 5 meters. That's a distance of 5 meters. But distance is different from displacement. Distance is a scalar quantity. It only has magnitude. So the length here, 5 meters. That's a magnitude. When we were doing vectors, we did this, right? Magnitude is the same as length, modular, size, right? So distance is a scalar quantity because it only has magnitude. It's 5 meters. That's different from displacement, which is distance traveled in a specific direction. So yes, the distance is 5 meters. But if I wanted displacement, I would say going from A to B, it's 5 meters to the right. Magnitude, which is the 5 meters, and direction, this arrow pointing to the right. That's the definition of a vector, and that's what displacement is, right? Do you understand that? The difference between distance and displacement?
Yes, ma'am.
Okay. And it's important for you to know the unit. You'll understand why later on. When we actually do questions, knowing the unit for each of these quantities would actually be very helpful. So displacement, the unit is meters. Same for distance, right? Speed is the distance traveled per unit time, and it's a scalar quantity. So back with this A to B thing. Let me say this is a road. I cannot draw, so yeah. Anyways, let's say this is a road and I have a car moving. And I told you that let me just use a circle to represent this car. And I told you that the car is moving at a speed of, well, this is kind of slow, but let me just say 2 meters per second. So for every second, this car is traveling 2 meters. That's speed, which is different from velocity. Velocity is the distance traveled per unit time in a specific direction. And unlike speed, which is a scalar quantity, velocity is a vector quantity because it has both magnitude and direction. So what exactly is the difference between speed and velocity? Well, on my diagram here, speed would tell me, okay, this body is moving 2 meters per second. But velocity would tell me this body is moving 2 meters per second to the right. Or you might say forward if it's a car that you're dealing with. Do you understand that? The difference between speed and velocity?
Yes, ma'am.
Yeah. Remember, you don't have to talk, right? You could always message me. It's very people who don't want to talk to me. Like, right. So this is just a note. Speed is actually the magnitude of velocity, like we saw here just now. Speed is a scalar quantity, it only has magnitude. And that was the 2 meters per second, right? But velocity is in a specific direction. So 2 meters per second, that is my speed, which is the magnitude of velocity. And then the direction was to the right. Or you might say forwards, if you're thinking about a car moving from this point to this point, right? So that's why speed is the magnitude of velocity. Remember to stop me if you have any questions, right? And notice they have the same unit. So that's fun. Meters per second, meters per second. Okay, let's move on. Continuation. Uniform velocity. What is uniform velocity? It's a constant speed in a fixed direction. Or instead of uniform velocity, you might hear constant velocity. It means the same thing, right? Constant speed in a fixed direction. So back to my car, 2 meters per second, moving this way to the right. Or let's just say forwards, right? It's going from this point to this house here to this house here. And it's on a road. And it's moving from here to here, going forward. Uniform velocity, aka constant velocity. So whenever you see uniform, they mean constant, right? It's constant speed in a fixed direction. So from this point to this point, throughout this entire journey, my car continues to move at 2 meters per second. It does not speed up, it does not slow down, it does not change direction. It continues at this speed, 2 meters per second, and it continues going forwards. Do you understand that? No, this would not change, this would not change. It continues traveling forward and it continues at this speed. It does not speed up or slow down. Do you understand that? If not, I can explain it a different way to help you to understand. But I need to know. Do you understand that? Yes or no? Would you like me to repeat it?
Understood.
Okay, cool. Thank you for responding to me. Yeah, especially for the exam students, this, how much time do you have? You have a little less than 2 months away from your exam. This is the time for you to ask as many questions as possible. And this is the time, if you know you were slacking before, you need to be paying attention right now, okay? It's very important. You cannot put all of this off until a month before your exam, 2 weeks before your exam. Start asking your questions now, yeah? Average speed. What is the average speed? It's the total, let me not use total distance traveled divided by the time taken. So back to my diagram because diagrams always help. I have this point, I have this point. Going from here to here, let's say the total distance is 5 meters, and it took me 10 seconds to move from point A to point B. So the distance between point A and point B is 5 meters, and it took me 10 seconds to get there. Then my average speed is the total distance, 5 meters, the total distance from point A to point B, divided by the total time, well, the time it took me to get there, the time it took me to travel this 5 meters, and I just said it's 10 seconds. So this would be 0.5, or you might say a half. So I'm just for 0.5 meters per second. And that's the average speed. That's how you calculate average speed, right? Do you understand that?
Yes, ma'am.
Okay. Let me just leave that there in case anybody wants to try it. Average velocity is the change in displacement divided by the time taken. So it's very similar to this, right? Except this is a scalar quantity. We said that. It has no direction. It has magnitude, so the 0.5 meters per second, but it has no direction. But if I told you okay, yeah, the distance is 5 meters, but my car is starting from a point B and going towards a point A. So let's just say instead of going to the right, it's going to the left. Still 10 seconds, right? So the distance is 5 meters, but I'm traveling to the left now, and the time is still 10 seconds. My displacement would actually be minus 5 meters. Why minus 5? So there's something about convention and all that that you would learn, I don't know, if you decide to do physics at Cape, you learn about convention and all that. But for now, let's just say to the right was positive 5, but to the left, it's the opposite direction. So it would be negative 5. When we were doing vectors, we did the same thing. A positive sign showed in one direction, but if I told you the negative of that vector, I just meant that there was a change in direction. So that's what I'm talking about here. Before, I had my point A, my point B, I had my car, and it was moving to the right. So my displacement was positive 5 meters. The magnitude is 5 because that's the total distance from A to B. And because I'm going to the right, my direction is positive. Not here. In this case, I'm going from B to A. My magnitude is still 5 because the distance between A and B is still 5. But I'm moving in the opposite direction. Instead of moving to the right, I am moving to the left. And that is why I said the displacement, not distance, displacement, which has both magnitude and direction, would be negative 5 meters. Do you understand that? If not, I can explain it again. I just need you to let me know. Just remember that I wrote my exam already. Okay, this is for you. So my displacement is negative 5 meters. The time is still 10 seconds. So my average velocity would be minus 0.5 meters per second. Magnitude is still 0.5 meters per second. So yeah, I'm still traveling at 0.5 meters per second. But this negative sign tells me that I'm no longer traveling to the right. I'm now traveling to the left. So for speed, it wasn't important. I did not need a sign. I could just put 0.5 meters per second and move on. Velocity, because it is a vector quantity and it has both magnitude and direction, I have to include the sign. And in this case, I'm moving to the left, which indicates a change in direction. So it has to be a negative sign. Do you understand that? Going once, going twice. Okay. Acceleration. I know it's a lot of definitions, but you really have to make sure that you know it, right? And they formulate too. Acceleration is the rate of change of velocity. Rate of change. Rate of, we just did rates, right? When we said when we hear the word rate, when we were doing rates of change last class, rate means with respect to time. So that means I'm dividing by time, right? And change of velocity. Change of velocity. For my physics people, you might see that as delta V. So whatever that is, let me just do the diagram because, like I said, diagrams always help for physics. And well, this is a physics-based topic, right? So for physics, diagrams always help. My car, it's moving to the right, 2 meters per second. That's at this point. This point right here. But then coming down to this point, I check this point. At this point, it's moving 2 meters per second and it's still moving to the right. But I then check this point. So it's traveling, right? It's going down, it's going down. I check again at this point. And I realize that the same body, so the same car, still moving to the right. But this time, the speed is now 4 meters per second. That indicates an acceleration. So my speed is 2 meters per second, speed is 4 meters per second. I would say the velocity is positive 2 meters per second. And then this one is positive 4 meters per second. That's my velocity. Oh, why am I putting second per meter? Meter per second. A change in velocity indicates an acceleration. What do I mean by acceleration? This car is actually moving faster and faster. That's what they mean by acceleration, right? 2 is obviously different from 4. 4 is obviously greater than 2. So because my velocity at this point here, let me just change the color of the point to green. Because my velocity at this green point is bigger than my velocity at this yellow point, that indicates a change in velocity, obviously, because 2 changed to 4, so change in velocity. And because there's a change in velocity, that means that there is an acceleration. Do you understand that?
Yes, miss.
Okay. Oh, and the time would be the time from this point to this point. So between these 2 points, what is the time? So from this point to this point, how long did it take me? Let's just say it took me 5 seconds. From this point, this yellow point, to this green point. So if I wanted to find the acceleration, let's say that's all the information they gave me. And they asked me to find, hold on, how much time do I have? Okay, and they asked me to find acceleration. According to my formula, acceleration is the change in velocity. So let me just go through this. V is the final velocity, which would be 4 in this case. U is the initial, which would be 2. Initial means the velocity you start with, right? And then T is the time taken between these 2 points. So V is 4, because that's my final velocity. U is my initial velocity, the velocity I start with, which is 2. And then the time taken between these 2 points, it's 5. So if this was the information that they gave me and they asked me to find the acceleration, then I would say A, let's just say the acceleration is denoted by A, is equal to the final velocity minus the initial velocity. So that's positive 4 minus positive 2. Let me just put the units. Minus 1 divided by the time taken, which is 5 seconds. 5 seconds. Oops. 4 minus 2, that's 2 meters per second divided by 5 seconds. So I can just leave it as 215, but the unit is meters per second squared. Do you understand how I got that? If not, I would explain how they got this s to the minus 2. Do you understand how they got that unit from this? Yes or no?
Yes, miss.
Okay. Good morning, Troy. Okay, so that's all your questions, like those. Continue. I know it's a lot of definitions, but bear with me, right? So uniform, like I told you, uniform, constant, same thing, right? So if they say uniform acceleration, they mean constant acceleration. which means the acceleration stays the same. That's what constant means, right? So, oh wait, no, I have one more thing to show you here. My car at one point, okay, let me just redraw that whole thing. Because I know this mix up students sometimes. At this point, we said we are checking those 2 points, right? The velocity at those 2 points. My car is moving 2 meters per second. So we said the velocity is positive 2 meters per second. But then when we checked at this point, let me just put a red point, it was actually 4 meters per second. And we said, since 4 is bigger than 2, well, it's different from 2. There was a change in velocity. And if I have a change in velocity, then I have an acceleration, which means that this car is actually speeding up or getting faster and faster. But what if I told you, yes, this is still moving to the right, 2 meters per second. But then I check this point here. But instead of it moving 4 meters per second, it's still moving 2. But in this case, it's moving to the left. What would you tell me? Is there an acceleration here or is there no acceleration? Do you think there's an acceleration or no? Going once, change time. Yeah. Okay. Well, yes. Why? Because there's a change in velocity. And you might be wondering, but how is there a change in velocity? It's 2 on 2. You need to remember velocity is not a scalar quantity, it's a vector quantity, magnitude and direction. So yes, my magnitude is 2. So let me just put mag. Yes, my magnitude is 2 meters per second. But what happened to the direction? My magnitude stayed the same, so it's 2 on 2, but the direction changed. And because there's a change in direction, that means that I have a change in velocity. So remember, velocity is not just about the magnitude, it's also about the direction. So even though my magnitude is the same, you might be tempted to say, oh, well, there's no change in velocity, it's the same thing. No, velocity is a vector quantity. So it's magnitude and direction I'm looking at. My magnitude is the same, but my direction changes. And because my direction